Everybody, welcome back to part 2 of Intro to Microsound. We're going to keep things rolling a little more quickly today. I'm going to try and get through as much as possible here. First of all, I just want to give a shout out to Nathan Tipton, who is one of the students from the original Intro to Microsound class at Experimental Sound Studio at ESS for making that sonic intro here. I'm excited to share that with you all. Nathan made that with some instruments that he made that are available as, I think, Max for Live plugins that have actually some gen running underneath. So please go and check that out. We're going to go ahead and get into some more mechanics of gen. And so the first point here that I want to make is that gen is different from max, right? And that's something that I've made in the last video that we're going to kind of continue to make. But here's another opportunity to say that. We have our metro object with a 500 millisecond operator attached to it at active 1. So it starts when the patch opens. We see the bang coming out of there. The bang is setting the contents of this message, right? And we don't see any of the gen stuff working. That's because digital signal processing, or DSP, must be on for gen to run. And so how do we check that? There's this little audio on off down here. We can also, if we have like an easy DAC, we can click that on and off. Or if we have a DAC here, we can send a 1 or a 0. DSP state will send out a 0 or a 1. We're also going to get our sample rate here. And that's going to become important in just a little second. But first, let's turn that on. You hear a little bit of noise, a little sneak preview of what's coming up next, or actually for number 5 here. And now we see everything is running, right? We see that the gen digital signals are updating. This would be the same as with any kind of MSP objects, but it's definitely worth making that distinction as frequently as possible. I am going to reset the size of the screen record here because I want to go ahead and open into this very first gen patch here. And so before I click in, what is this doing? Well, we can kind of take some context clues here. Out of the first outlet comes this number 44100. That's also what DSP state is outputting as the sample rate. So we see that the sample rate is being output here. That's not changing. This middle number here is changing. What is going on with that number? How is it changing? Well, it seems to be going up, faster than we can count, really. On the far right, this third outlet, we do see that this number is also changing. How is it changing? It is also going up. How is it going up? It is going up by 1 at a rate that we can count and maybe even recognize as a standard numeric value, a standard durational quantization called a second. So this is the math inside of here. This is the first time that we are going to see a couple of these stock operators inside of gen. These are something like system variables. Like if you're using processing, frame count is like a system variable that is going to deliver the number of frames that have elapsed since you started a sketch. In gen, we're using 2 here. There are several others that aren't coming to mind, but sample rate. Right, so sample rate is just a 1-word operator, no arguments, no inputs, just 1 output. And that goes out of out1. We give it this code name here, sample rate, this label, so that I think we should be able to hover over this and it's going to say sample rate there, fantastic. And out it puts 44100. Elapsed. So out 2 is elapsed. So that is the number of audio samples that have elapsed. The sample rate, 44100, is the number of samples per second. So if we take the number elapsed of samples and divide it by the sample rate. We round that down to the nearest or the lowest integer nearby, rounded down. And we're going to get the output in seconds. So this is a very simple seconds counter. So far, this probably doesn't seem super useful to us, right? Metro can kind of do this, can really do a very similar thing, right? It can also keep track of seconds. We could say Metro at active 1 and give it an argument of 1000 and then make a counter. And we're pretty much doing the same thing, right? Yeah, we're doing something very similar. These similarities, definitely, you're not going to get me to say anything different about them. Sometimes a metro with a counter is going to be just fine. Why we are spending time with these very small, like rebuilding metro and counter, is that this is going to be useful for us in the long term. This is going to be useful for us as we do, as we start to structure sonic processes over longer term. The other really important thing is that this is sample accurate, which means that gen is sample accurate, I should say, whereas there may be some deviation according to how the CPU is scheduling max operations. So again, for a lot of stuff, we're not going to really be too concerned about exact 1 second timing, but with some things we may be, and gen is going to be very useful there. Right, we don't quite have the use case in front of us, but we do want to start to expand here how we might structure this counter. This is a very similar structure. We can kind of see these side by side here, right? Yeah. Great. So here's the first one. We have sample rate divided by elapsed. Similar. We have sample rate, which is dividing and round and outputting seconds. So this is still a seconds counter. But we may not want the timing of musical events, the timing of like note events or finer grained sonic events to only be in reference to the elapsed number of samples since we started the DSP. Though, you know, sometimes that may be helpful if you're initializing something. Often we want to reset our counter. So elapsed in many cases won't be helpful for us. In that case, we have this accum, which is an accumulator. So in the left input here, we put the amount to add. And so this is also a formulation that's probably going to be look a little novel to us, right? We're not going to, in Vanilla Max, have the ability to make like a one. Oh, well, I suppose we can make a one object. That's actually new to me. Oh, so this is an int. Oh, wow. Okay. So this is then by default an int object. Well, okay. I've just learned something. You don't see that often. Even if I have an int object like this, right, I still need to send a bang in or else nothing comes out, right? In this case, gen code is always running. It's always running. So we don't need to send a bang here. It by default sends a one out. So one goes into the left input every single sample and adds to the amount which has already been accumulated. These numbers now look identical. The simple seconds counter and this accumulator. What is unique about this is that we can send in some value which isn't 0, and that is going to reset our accumulator. So here, going into the first inlet, which is mapping up with our in1 here, I have this click. And a click will convert a bang into a 0 to 1 impulse, basically a trigger. Think of that as a click or a trigger. We'll talk about them interchangeably. Now, when I click, those two things go back to 0. So let's maybe convert this into some language which is a little more familiar. The LFO, low frequency oscillator. This is a basic way of structuring sonic processes, rhythmic, sequential processes in analog synthesis. It is also a way that things are structured in the book, which I mentioned last time, Generating Sound and Organizing Time. Things are organized according to ramps, movements from 0 to 1. And so here we have a different kind of display. This is our dear friend live.scope. So this is an Ableton Live device here, or not device, but object, really handy for visualizing these kinds of audio signals. We're going to use it, or visualizing signals, be they audio signals or control signals, as we might talk about in LFO. We're going to use that throughout. When I turn audio back on after Max crashed here, we'll see that the right inlet is looping between 0 and 1. So if I open this up here, we're going to see that the only difference between the accumulator and reset and this LFO phaser is that there is this wrap 0 to 1 inserted between the division and the out 3, which I suppose is not out 3 well, sort of in seconds, but out 3, this is like our LFO, right? So this can be really useful for structuring events here. We might also want to change the frequency of this. Right now, this is just looping between 0 and 1. It is looping between 0 and 1 every second. But if we change the value that is added into this accumulated total here, we effectively change the frequency. So if I bring this all the way down here, well, actually, can I do this here? No, I can only do this here. This is really more of an LFO range, right? This is just about every 2 seconds here. This cycles back. So this could be, something that's structuring like a change in reverb amount or amplitude or filter gain, filter frequency, et cetera, et cetera. But if I turn this volume up and start to increase this, we'll get into the audio range here. Let me fix my audio settings. Great. So now we can hear this as well. And so this is a waveform just like this. We're going to see that there's a little, like a tiny bit more going on under the hood here. This is also just taking the result of sample rate divided by the accumulated total and wrapping it between 0 and 1. The raw phaser, I guess, is coming out right here of the third outlet. If I connect the fourth outlet, we'll see that it looks a little different. That's because this fourth outlet is getting a little bit of reverb. This is another really handy gen operator, freeverb. Mix is basically mixing two signals together, this one and this one. So it would be basically it's a wet and dry. And then you can give it an argument here between 0 and 1, which will be, this will be basically 50% reverb, 50% unreverbed signal. And so now we have basically a phaser, right? We have this waveform here. We can adjust its frequency. But remember also, we have this ability to reset the accumulator here. And if we do this at this lower frequency, right? Like if we imagine this like triggering a note or like triggering like maybe a sample playback or something like this, it would create kind of like a stutter effect. When we're at audio rate here, this will create a small sort of, it'll create a spectral effect, which is called a sync. Well, I'm not sure what spectral effect would be called exactly, but we are basically force syncing the waveform back to its start. So you can hear some timbre shift here as I just click this. The very last thing that I want to point out is that we can actually tie these two processes together. So what if this LFO or something like this LFO, I've recreated it here, is automatically every time it reaches its peak and goes back down to 0, what if it is triggering a reset? We can get a cool sync effect. So this VCO here is just like this. It has this click which is resetting. This is just a bit of logic here which I've composed in MSP objects as opposed to Gen, just to kind of like, I don't know, simplify some things. What this does is it looks at the change between each sample slope, and it will take the absolute value. Basically, when it gets to the top and it goes back down to the bottom, the change between each sample is going to be big. It's going to be actually bigger than 0.5, and it's going to output a click or a bang rather, which will then trigger our VCO to change frequency. So we can get different effects as we increase and decrease this LFO. We don't have to keep it in LFO range. We can go into a higher audio range. You can actually hear then this audio artifact here at more of a rhythmic rate. I've also included this slider interface here too, which allows you to change things a little more gesturally. Okay, that's it for today. I wanted to include something that at least made a little bit of sound and like immediately gave us kind of a fun use case. We're going to keep building on as we continue here. Next time we'll check out 1.3. Looking forward to seeing you all in the mix there. Thanks again to Nathan Tipton. If you like this video, like it and give a comment. Let me know. We're going to release a few more of these before we do like a social media push. But happy that some folks are already checking it out. And we will talk to you all next time. Thank you.